Okay, so this problem, we're going to look at, given this region, y equals 3x minus x squared, which is here. And we're trying to revolve this about the y-axis. And, so we're gonna need to use the shell method, okay? It's required to use the shell method. So how do we construct this? You have to be very clear that when we use the shell method, inside of the integrand, we need to calculate the volume of that shell, okay, the volume of that shell. So basically speaking, we're trying to construct something like this, So this is one of the small shells you can think of, okay. So to figure out the volume of the shell, we basically need to have three compartments, We need to know the radius, we need to know the height, and we also need to know the thickness, okay. The thickness, when we're trying to use shell method, it's easy to standardize. Either it's dx or dy, okay. So that stands for the thickness. And when we have the radius, we can figure out the circumference and then multiply the height, and then times the thickness. That gives us the volume of this shell, okay. So that's the first thing you need to know. Second, different with the disk or washer method. When we're trying to use the shell method, the integral, it's gonna be with respect to the perpendicular axis to the revolving axis. Okay, that's a little bit, if you revolve about the y-axis or a vertical line, you know that the corresponding axis that is perpendicular to the revolving axis is x-axis, okay? So then the shell method is going to be in terms of x, okay? So that's the first thing you need to be very, very clear, okay? So with that in mind, you see this is the thickness. With that in mind, all we need to do is to figure out the radius and the height, and then we're done, okay? And both of them in terms of x, okay? So you can see that the radius, which is exactly the x here, right? So as x is moving larger or smaller, right? And then the corresponding y, the height, is exactly the y for this point, which is 3x minus x squared. So the so this is Rx, this is high x. So the radius in this problem, which is exactly x, and the height, which is exactly y, in terms of x, which is 3x minus x squared. Okay, so the volume of this shell is going to be the circumference, which is 2 pi times Rx, which is x, and then times the height, which is 3x minus x squared, okay, and then times dx. So this part stands for the volume of this general shell, okay, of this general shell, and it's from 0 to 3. So the next is just to evaluate this one, pretty standard thing. So it's 2 pi, I take it out, 0 to 3 is going to have 3x squared minus x cubed, right, dx. And then it's 2 pi, and then let's have x cubed, okay, minus x to the power 4, so over 4, from 0 to 3, okay. So with that in mind, we can do 3 cubed minus 3 to the power 4th over 4 and 2 pi. This is going to be 27 minus 89 over 4. Okay, so we can do this 108 over 4 minus 81 over 4. Turns out this is 2 pi times 27 over 4. Okay, so which is 27 pi over 2. Okay, so and then we done for this one. Okay, so the key note for this example is to know that shell method, when you construct in terms of a volume of a general shell. Okay, and also how do we set up the integral with respect to which one? So yeah, hope you enjoy this video. Thank you.